Hi, welcome back to the physics session. In this session, we will discuss worksheet questions of gravitation. Very first question is, let the escape speed of an object of the earth is V0. The object is projected out with a speed 5 V0. The speed of the object far away from the earth will be, that means at infinite distance from the earth, what will be the speed? Projected speed is 5 V0. Let me take another color. If, the projected speed is 5 V0, where V0 is the escape velocity. He said that only, right? Escape speed, yes. In order to confuse you, he gave V0. So people will confuse that it's an orbital velocity. Now, what is the velocity at infinity? That is the question. What is the velocity at infinity? Okay, we have one formula, that is if the projected velocity is k times of the escape velocity and k is greater than 1, then velocity at infinity is square root of k square minus 1 into ve. As per this, v at infinity is equal to, let me take another color, v at infinity is equal to square root of, what is k value here? K value 5. So 5 square minus 1 into V0. That is square root of 25 minus 1 into V0. So that is root over 25 minus 1, 24 or 24 V0. So no option like this, so we'll change it. 24, 4 6 are V0. So it must be 2 root 6 V0. Now there is an option. So answer will be this way. Okay, let's go to the another question. A uniform sphere A with radius r exert a force F on a small particle situated at a distance 2r outside from the center of the sphere. A spherical portion of diameter r is cut from the sphere A as shown in the figure. Okay, if F is the new gravitational force between the remaining portion and the particle B, then correct relation between F and F dash is, okay, so effective gravitational field you have to calculate for the force. Force is equal to, just like EQ, here IM, okay, that we have to use. That is the logic and idea. We'll do like this. First of all, this is a whole sphere. This whole sphere will have field at a distance 2r is, whole sphere field at a distance 2r is, its mass suppose say m. Okay, yeah, field is, I can call it as total field, no issue. I is equal to, that is nothing but acceleration due to gravity only, that is g m by r plus h whole square, r plus h, that is center to center, distance is 2r only, I can take directly r plus r, so 2r whole square, that only. So this is clearly gm, okay, gm by 4r square. Wow. Next, what about the cut portions? Cut portion, see, suppose this is another picture I will draw here, so that it has taken a cut like this, and here to here the distance will be how much? What is the cut one? Diameter, a spherical portion of diameter r. Diameter r means here to here is r by 2. R by 2 is lesser, so here to here is 3r by 2, isn't it? Total 2r, in that r by 2 should be removed, so that should be 3r by 2. The distance is 3r by 2. Now what I am trying to do is, this is whole mass gravitational field. Now I am taking gravitational field of the small sphere, gravitational field of the small sphere or cut sphere, whatever. So before cut, if it is not cut, how much it is going to produce the gravitational field? how much it is going to produce the gravitational field. That I am trying to. For that, you need to know G, color is not good, G, G, mass of that particular thing by distance. Distance is 3r by 2. Okay, anyway, we can use. So here, I need to calculate mass. You see, r cube volume contains a mass of capital M. Then r by 2, that is r by 2 only, you know, the radius is r by 2 only. R by 2 cube contains how much mass? M by r cube into r cube by 8. So it is nothing but m by 8. Its mass is m by 8. Okay. So cut portion moment, cut portions field is G m by 8. R is the distance, 3r by 2. 3r by 2 whole square. 3r by 2 whole square. So its a simplified form will be Gm by 8 and 9r square into 4. So it will be 4 will go 2 times, huh? Yeah. Gm by 18r square. This is cut portion gravitational field. Whole gravitational field, that one. Okay. So remaining gravitational field is whole minus cut portion. So whole is Gm by r square on removing 4 cannot be taken common. Huh? Okay. So here even 2 can be taken common. So that direct step up. So 1 by 2 whole portion. See here 4r square is there. I took common of 2r square. So 1 by 2 will be there. Minus 1 by 18 is there. In this 2r square I want to remove. 2r square, then 9 will be there. Yeah. So remaining portion moment, what you call this field is, how much will be? 9 minus 2. 7 by 18. Huh? Okay, 7 by 18. I'll write here. Remaining portion, I will write here. Okay, no problem. Remaining portions gravitational field is Gm into 7 by 9 2s are 18 2s are 36 r square. So now first force F, he is asking first force F is equal to I into a small particle, some a small particle mass I want to write as m naught by this is whole, right, and by f dash is remaining portion into m naught. So force is equal to I m naught. M naught gets cancelled. Then IW value is whole. Gm by r square gets cancelled. Why should I write the complete thing? I'll write 1 by 4 here, by here 7 by 36 I'll write. So it is going to become 36 by 36 will go up 4 into 7. So 4 ones are 4 nines are. So 9 by 7 f by f dash. So which option will come? F dash is equal to 7 by 9f. Correct only. Cross multiplication. What's that? F dash is equal to 7 by 9f. Which option that is? F dash equals 7 by 9f. C option, correct? Okay. Yeah. Now you can clearly observe. I repeat at a glance. Whole body causes some gravitational field. So thereby a force. Cut portion causes some gravitational field. Remaining portion causes remaining gravitational field. So remaining portion gravitational field is whole gravitational field minus cut portion gravitational field. So that on subtraction you will get like this. Okay. Yeah. Next. 3 particles each of mass m situated at the vertices acting on the particle are their mutual gravitational forces on the particles. Okay. it is desired that each particle moves in a circle while maintaining the original separation is L. Okay, the initial speed that should be given to each of the particle is equal to, there are three particles, okay, three particles, fine, each of mass m, okay, fine. Instead of this, I'll draw first a circle because they are on circle, right? Acting on a part, situated at the vertices, acting on a particles are their mutual gravitational force, desired to move in a circle. So first let me draw the circle. Okay, now here is one mass, here is another mass, and here is another mass. So three masses are there. Okay, and their initial separation is L. Not drawing good. Yeah, let me take another color. It didn't like the color. So, yeah, this is L. This is also L. Triangle ray. Don't laugh. This is also L. Okay, so it's a triangle. Original separation L. The initial speed should be the speed means V, normal V, that we have to find out. See, actually circle radius will be that we have to find out. Circle radius. See, that is centroid to vertex. Centroid to vertex is A by root 3. That means L by root 3. L by root 3 is what you call radius. R is equal to L by root 3. This is needed. Next, gravitational force between two masses is this way. Gravitational force between two masses is this way. This is attracted by these two, M getting attracted, and this M also getting attracted. So this is 30 degrees. So it's one F force, one of the component is F cos 30. This one also F cos 30. So 2F cos 30 must supply necessary centripetal force mv square by r. So I repeat, this color. This force is resolved into two components, this way and this way. So this is F cos 30, that is also F cos 30. So total 2F cos 30. So 2, what is F? G m1 m2 by r square. G m1 m2 by distance square. What is the distance between two masses? L square into cos 30. हमारे देश में √3/2 cos 30, and m here is capital M only, m v square by r is L by √3. Here everything is in L, not in r, so we have to adjust in such a way. Now 2 gets cancelled, wow, gets cancelled, wow, and G m √3, 1L will gets cancelled, that is equal to V square by L gets cancelled. So okay, I'll write here square and cut, and L cut, and this √3 will come here. √3 also will cut. So V is equal to square root of G m by L. Wow. A satellite revolving around the earth at a certain height experiences acceleration due to gravity. A satellite revolving around the earth at a certain height experiences acceleration due to gravity equal to acceleration due to gravity G dash is equal to 16/49 G naught. Okay, where G naught is the acceleration due to gravity on the surface. If R is the radius of the earth, then square of time period of the satellite of revolution equal to k times of square of time period of the satellite is k times of pi square r cube by gm. The value of k is the value of k. Okay, value of k he is asking. Fine. That is acceleration due to gravity they gave. T square is equal to k times of. So if it is the acceleration, what would be the radius? That I have to find, right? So if it is the acceleration, radius is, we have what we have, gh is equal to g into r by r plus h whole square, isn't it? So r plus h I want, actually r plus h I want. This GH is 16 by 49 G equal to G into R by R plus H whole square. So G gets cancelled. Taking square root 4 by 7 is equal to R by R. So small r is equal to 7R by 4. This is the radius of the satellite. Radius of the satellite and time period are having relation like this. T square is equal to directly r cube only people knows, but there is a constant behind that. T square proportional to r cube everybody knows. What is the constant behind that? That is gm by 4 pi, 4 pi by gm. This is 4 pi by gm because I wrote constant in this side, right? So 4 pi by gm, 4 pi by gm, 4 pi square by gm. Yeah, 4 pi square by gm. So now T square is equal to 4 pi square by gm into r cube. R cube means which r I have to write? 7r by 4 I have to write. 7r by 4 cube I have to write. Yeah. So now 4 into 7 cube into r cube into pi square by gm by 4 cube is also there. 4 cube. So r cube, pi square, gm everywhere, this is setting to it. We have to find out this k value is nothing but the number. So k is equal to 7 cube and 4 ones will go. So 4 square. 7 cube by 4 square. 7 cube by 4 square is 4. 4s are 16. Denominator 16, only one option. So use some. Don't waste your time in 7 into 7 into 7. 7 sevens are 49, everybody knows. So that is the thing. So it sense, right? Yeah, option B. Next. A planet is moving in an elliptical orbit around the sun. A planet is moving in an elliptical orbit around the sun. Okay. The work done on the planet by the gravitational force of the sun is 0 in no part of the motion, is 0 in some parts of the motion because it's elliptical path. That's what his intention. Is 0 in one complete revolution and is 0 in any small part of the orbit. Which of the following is true? Right? So read the question once again and try to come to a conclusion. Planet is moving in elliptical path. Is 0 in no part of the motion is a wrong option. Is 0 in some parts of the motion is 0. Why? Because at certain places A is perpendicular to displacement. Radius is perpendicular to displacement. Obviously, we will have 0. 0 in one complete revolution. It's a conservative force. So this is also true. This is also true. Next is 0 in any small part of the orbit. Which of the following is true? So this one comes to true. Yeah. Okay. Next. A planet is revolving around the sun. In which the following is correct statement? Planet is revolving around the sun. Which is the correct statement? That is the question. Read out the options. Read out the options. Read out the options. The time taken in traveling DAB is less than that of BCD. Both are equal, what you call symmetric parts. Next, the time taken in traveling, actually you shouldn't think like that, it should be thought like this. Here to here, right? This is sun. So radius vector sweeps equal areas in equal intervals of time. So this area, okay, and this area. If you observe these two areas, will it be same? No. This is lesser, this is more. So radius vector sweeps equal areas in equal intervals of time. So first option is correct only. Next. Time taken in traveling DAB is greater than BCD. DAB is greater than BCD. Obviously it's wrong as you accepted first one. Time taken in traveling CDA is less than that of the ABC. CDA less than ABC. This is same only. Okay, so he is telling less, so wrong option. Actually they are same, and so obviously that is the thing. So option A. Consider a spherical planet which is rotating about its axis such that the speed of the point on equator is v. The effective acceleration due to gravity on the equator is 1/3 of its value at the poles. What is the escape velocity for the particle at the point of this planet? This is a separate planet actually. Consider a spherical planet which is rotating about its axis such that the speed of a point on the equator is v. So it's a planet is revolving and here the speed is v, rotating, right? Yeah, rotating. Next, the effective acceleration due to gravity at the equator is, he gave g at the equator is equal to 1/3 of g at the poles. Okay, next, actually the relation between g at the equator is g at the equator is equal to g minus r omega square cos square phi. Here cos square phi is 0 degrees. That means g poles it is. So g poles minus r omega square, okay, that is equal to g poles minus, what is omega? V by r. So r v square by r square. So you are going to have gp minus v square by r, that is equal to ge. This you are going to get. Next, what is the escape velocity of the planet at the pole of the planet? What is the escape velocity? What is escape velocity basic formula? Escape velocity is equal to square root of 2gm by r. Or you have another formula, square root of 2gr, where g is poles 1 only. So this is escape velocity. So you need to manipulate this and that such that you need to get a proper and better option. For that we'll try. So let us manipulate the things. These two equations must be converted into one form. That is GE is equal to 1/3 of GP, right? Yeah, GP. That is equal to GP minus V square by R. So V square by R is equal to GP minus 1/3 GP. So this is equal to 2/3 GP. This is V square by R. Now let us replace. Escape velocity is equal to square root of 2 into, this is here what we are writing, GP, 3 ones are 3 minus 1, 2 by, okay. Now GP I want to replace. GP is equal to 3 by 3V square by 2R into R. So here what are the things going to cancel? R, 2R gets cancelled. This will be 3V square. So it is root 3 into V. Root 3 into V, option C. Let me check. Yeah. Next. So whatever the given things we have to write, and we have to transform the equations in order to obtain the respective options. There is no specific path for this type of things. Only practice will make the sense. Next. From the pole of the earth, a body of mass m is imparted a velocity v0 directed vertically up. If m is the mass of the earth, r is the radius, and g is the free fall acceleration on its surface, then the height h to which the body will ascend is, don't tell that h is equal to u square by 2g, because g value are not same as it goes up and up and up. So we need to think about law of conservation of energy mode. In that aspect we have to answer this question. A body is imparted velocity v0, so it attains a height h. Suppose you need to go for what you call law of conservation of energy. That one will make some sense. Suppose this is the earth surface and you are imparting body a velocity v0. So on reaching to a maximum height, velocity, final velocity will become 0. Okay. Next, the height h to which the body will ascend, H. So you have law of conservation of energy. So potential energy plus kinetic energy on the surface, potential energy plus kinetic energy at the top, but maximum height I can say. So H is equal to H. So potential energy minus Gmm by R plus kinetic energy half m v naught square is equal to potential energy minus Gmm by R plus H. This H we need to find out, plus kinetic energy 0. Always Gm can be replaced with Gr square. Okay, so Gm can be replaced with Gr square. First of all, I can cancel m. Next, what I can do? Minus Gr square by R plus half V naught square equal to minus Gr square by R plus H. This H I want actually. Okay, this term, the similar terms on one side. 1 by 2 V naught square is equal to Gr square of 1 minus 1 by R plus H. And here also R is there. Why shouldn't I cut R here? So it will be better. Huh? Again R will come. So I can write here R only. Now what I did? Gr square I took common and bringing on one side, right? So V naught square, what we want? H we want, okay. V naught square by 2 is equal to here Gr square into cross multiplication also takes time. So okay, so here R into R plus H only, and this will be R plus H minus R. So RR gets cancelled. Later we will divide with R. Later we will divide with H so that it will be good for us. So next, V naught square by 2 is equal to now G R by R plus H into H, right? Now divide with H so that it is 1 plus R by H. V cross multiplication 2Gr V naught square will do like this. R plus H is equal by H is equal to G R into 2 by V naught square. What I did, just R plus H by H on one side, remaining things on other side. Now this is R by H minus 1 plus 1 is equal to 2Gr by V naught square. So R by H is equal to 2Gr by V naught square minus 1. Next, H is equal to, I'm just doing everything fast. That means V naught square is made LCM and that thing will come on to denominator 2Gr minus V naught square, and here R into V naught square, isn't it? After, yes, yeah, this is H. Option B. Next, simple mathematical things. A body is of masses 100 kg, M1 is equal to 100 kg and M2 is equal to 8100 kg, are held at a distance 1 meter, R is equal to 1 meter. The gravitational field at a point on the line joining them is 0. Okay, the gravitational potential at that point is, that means null point he is asking, x is equal to null point m2d by m1 plus m2, right? 8100. Let me write the formula, otherwise x is equal to r by square root of m2 by m1 plus 1. So x is equal to, what is r value? 1 meter by, I'll take in meters only, okay, no problem. Square root of m2 is 8100 by 100 plus 1. So this is 1 by, zeros will go, root 81 will be 9. 9 plus 1 will be 10. x is equal to 1 by 10 meter from m1. Now potential V is equal to V1 plus V2. Gravitational potential is negative G m1 by x from first one minus G m2 by r minus x is from the second one. So we need to simplify this task. That is equal to what I can take common G or m1 m2s are different. Oh, very big calculation it has. Okay, I'm just taking another color. Yeah, no, same color here. Yes, minus G can be taken common. Remaining things cannot be. X plus m2 by r minus x. So minus 6.67 into 10 to the power of minus 11 into m1 100 by 1 by 10 plus m2 8100 by r minus x, that is 1 minus 1 by 10. Okay, so that is equal to, I'll write currently G only, later I will take up. This is 1000 plus this is 9 by 10, so 9 will go 9, so 9000 it is. Yeah, so it will be 10,000. So G into 10,000 means 10 to the power of 10,000 means 10 to the power of 4 and minus 11 will come here. This is minus 6.67 as usual. So it will be 7. So option C. C or A? A also 7 only. Oh, this is 13.34. Okay, so it's not correct. This is only correct. Yes. I thought that all numbers are same. Okay, next. The escape speed of an object on the surface of the earth is v. If the object is thrown out with the speed 4v from the surface, the speed at a so far distance is equal to. So similar type of questions came so many times in the previous years. That is, whenever a body is projected with k times of the escape velocity, infinite distance, what will be its velocity? Square root of k square minus 1 into escape velocity ve. So it is projected with which velocity? 4 times, k value is 4, 4 square minus 1 into ve. 4 4s are 16 minus 1 15, root 15 ve. So answer is, so option also came early only. Oh yeah, next. Two planets A and B orbit around a star which two planets A and B orbit around a star such that time period of A is 8 times. The ratio of orbital velocities of the planets A and B is, two planets A and B orbit around a star such that their time period of A is 8 times, time period of A is 8 times time period of B. Ratio of their orbital velocities of the planets, ratio of their orbital velocity, V naught A by V naught B. So orbital velocity and time period relation, orbital velocity and time period relation. For that, first of all, let us find out the radii of their orbits. That is, see, we have t square proportional to r cube. So I can write for two bodies like this. R RA by RB is equal to, RA by RB equal to TA by TB. First of all, their squares and divided by cube. So this is what we have already. What is TA by TB? TA by TB is already given. TA by TB. TA by TB is 8. So 8 whole to the power of 2 by 3. Cube root will be 2. 2 square will be 4. This is 4. Now orbital velocity. What is orbital velocity basic formula? Orbital velocity basic formula is square root of gm by small r. That only we are going to write r plus h. So small r. So obviously formula will become like this. RB by RA So that means what is RB by RA? RB by RA is 1 by 4 because this is RA by RB 4. RB by RA 1 by 4. That means 1 by 2. That means 1 is to 2. Okay. So whenever options contains 2 is to 1 and 1 is to 2, you should be very careful. Both options, when I see 4 is to 1, 1 is to 4, like that options are there. You need to check twice, right, before opting. Very careful, because even after knowing the concept also people will lose the marks. Be careful. A projectile is thrown straight upward from the earth surface with a velocity v is equal to some ve, where alpha is a constant. Okay, v is equal to alpha ve. Okay, and v is the escape velocity of the speed. Okay, the projectile travel up to a height 800 kilometers. H is equal to 800 kilometers. Okay, on the surface of the earth before it comes to rest. The value of alpha is equal to, yeah, H is equal to, we have a good relation. H is equal to k square by 1 minus k square into r. K square by 1 minus k square into r. So that relation we will use. What is that? K square. That means here alpha square. Alpha square by 1 minus alpha square into 6400 is equal to 8000. So radius 6400 only they gave. 0 0 0 0 cut. So 8 8s are. So 1 minus alpha square by alpha square is equal to 8. So it is 1 by alpha square minus 1 is equal to 8. So 1 plus 8 is equal to 1 by alpha square. So this is equal to 9. 1 by alpha square is 9. Then alpha is equal to 1 by 3. So or 0.33. 1 by 3 only there. Okay, fine. 1 by 3. So this is here the formula, China. You need to notice this. Height attained when a particle is thrown with k times of escape velocity and k is less than 1. Height attained is given by k square by 1 minus k square into r. Okay. Next. Angular speed, linear speed, kinetic energy change with time, but angular momentum remains constant for a planet orbiting the sun. What's that? Angular speed, linear speed, kinetic energy change with time, but angular momentum remains constant for a planet orbiting the sun. Angular momentum is constant as no torque is acting on the planet. So what will be our option? Obviously both are correct only, because nothing to argument here, right? Both are correct and is a correct explanation. Next, a geostationary satellite is taken to a new orbit. A geostationary satellite is taken to a new orbit. Okay, such that its distance from center of the earth is doubled. Such that its distance from the center of the earth is doubled. Okay, then find the time period of this satellite in new orbit is. First of all, time period we want. So T2 by T1 is equal to R2 by R1 whole to the power of cube by 2. Yeah. T2 we have to find out. T1 is T1 here. And R2 is 2 times of R1 they said by R1 whole power 3 by 2. That means this is T1, R1 gets cancelled. So 2 to the power of 3 by 2. 2 to the power of 3 by 2 is 2 cube. 2 cube is 8. 8 root is 2 root 2. So T1 2 root 2. T1 is 24 hours. 24 hours into 2 root 2. That means 48 root 2 is T2. So hours. Yeah. Acceleration due to gravity at a height. Acceleration due to gravity at a height is 1 by 20th. Acceleration due to gravity at a height 1 by 20th of the radius of the earth is. He didn't give acceleration due to gravity. He is asking about acceleration due to gravity. Wait. So that's why without reading the question properly, we shouldn't come to a conclusion. The height h is equal to r by 20. Radius of the earth above the surface, and earth surface is acceleration due to gravity at that place is 9, he said. Its value at an equal depth below the surface is GD is equal to how much? Same depth. R by 20 is not a simple one. We shouldn't use 1 minus 2h by r because it's not a small one, it's a large one only. So GH is equal to 9. So GD will be how much? Okay. So GD is equal to G into 1 minus 2h by r. 1 minus d by r. This is depth, no? Right. Now GD is equal to, I'm going to write, we have to find it. GD is equal to G value into 1 minus d by r. D value how much? R by 20, he said. R by 20 into r gets cancelled. It will be G into 19 by 20. This is GD. Still story not over. We need to convert it into that values. Yeah, story not over here. As he has given GH is equal to 9, we have GH is equal to G into R by R plus H whole square. This is, he has given 9. 9 is equal to G into R by R plus, what is H? R by 20 whole square. So 9 equal to G into, here RR gets cancelled. This is 21 by 20. 20 by 21 whole square. So small g is equal to 9 into 21 by 20 whole square. That we need to replace here. So that is equal to 9 into 21 by 20 square into 19 by 20. So 20 is 400, 21 square, 19, all these roughly it is coming to 9.49 something. 9.49 is analogous to 9.5 meter per second square. So option must be C. Yeah. Next. Mass M is divided into two parts, M and 1 minus x into M. Okay, that means mass M is divided into two parts. One is x fraction of M, another one 1 minus x fraction of M. Okay, actually, okay. The value of x for which the gravitational attraction between the two pieces should be maximum. To have maximum attraction, they must be equal. So xm must be equal to 1 minus x into M. Then only the two forces will be equal. So 2x is equal to 1, x is equal to 1 by 2 for maximum force. For maximum force, x is equal to 1 by 2. So option A. At what height from the surface of the earth the value of acceleration due to gravity will fall? At what height the value of acceleration due to gravity will fall half that of the value on the surface. So this is equal to G into GH formula I want to write. GH formula. GH is equal to G into R by R plus H whole square. So let me take these two now. So 1 by 2 is equal to 1 by root 2 is equal to R by R plus H. So R plus H by R is equal to root 2. 1 plus H by R is equal to root 2. So H by R is equal to root 2 minus 1. Root 2 minus 1. Then H is equal to R into root 2 minus 1. Is nothing but 6,400 kilometers into 0.414 because 1.414 minus 1. So it's almost 6 4s are 24. So all are on 2 only. You have to multiply and you need to find it up, right? Because all are close. All are very close. Be careful. Huh? Next. Kepler's second law is nothing but a statement of law of conservation of angular momentum. Law of conservation of angular momentum. C is correct option. Angular velocity of the earth with which it has to rotate so that the acceleration due to gravity on 60 degrees latitude will be 0. We have g phi is equal to g minus r omega square cos square phi. He is telling if it is 0, what will be omega? If it is 0, what will be omega? G is equal to r omega square cos square 60. R omega square cos square 60 means cos 60 1 by 2. 1 by 4 is equal to G. Now omega square is equal to 4G by R. Even R value is substituted. Oh my goodness. Okay. Omega equal to square root of 4G by R. So 2 root G value 10 by R value 6400 into 10 power 3. So 100 go, here 4 zeros are there, so 2 by 100 will come into 64 root is 8 8s are 64, 2 will go 4 times, so it is 1 by 400. 1 by 400 thing will come as omega, radians per second only answer will come. So 1 by 400 is 1 by 4 is 0.25, correct only. Next. A semicircular plate of mass m has radius r and center c. Semicircular plate. The center of mass of the plate at a distance x from its center is c. Its moment of inertia about the axis passing through the center of mass and perpendicular to the plane is. So he is asking moment of inertia about that axis. See, I is equal to ICM plus mx square. So this is mr square by 2 minus mx square equal to ICM. So option must be D. Next. A planet is revolving round the sun as shown in the figure. Okay. Okay. Good picture. The radius vector joining the sun and the planet are at points A and B are so. Here letters are missing, maybe RA and RB. We will observe the option, okay, and I can call it as RA and it is RB respectively. Okay, the ratio of velocities of the planet at that points A and B when velocities makes an angle with the major axis of as respective things, the orbit is. So observe the picture carefully. Here the angles are also given. Now we need to go for conservation of angular momentum so that we can get everything. So we need to use law of conservation of angular momentum. M1 M only, mass same only, M1 V1 sin theta 1 equal to M2 V2 sin theta 2. So M gets cancelled. M same only, no, mass same. So I to write M2 M only. Next. We are ratio of velocities v1 by v2 equal to sin theta 2 by sin theta 1. Sin theta 2 is sin 60 by sin 30. Sin 60 root 3 by 2, sin 30 1 by 2. So it will be root 3 is to 1. So option B. I have to set that also. Yeah, did we check M1, V1, R1, right? Where is R1? What happened to R1? This is R1, M1, V1, R1 sin theta. This is M2, V2, R2 sin theta, right? So V1 by V2 is equal to sin theta 2 by sin theta 1. Obviously R2 by R1 is also there. R2 by R1 is also there. R2 by R1 is also there. R2 by R1. So root 3 by 1 into R2 by R1. R2 is 60 into 10 to the power of 6 by 90 into 10 to the power of 6. So this will go, 0 0 will go, 3 table 3 times 2 times. So then 2 root 3 by 3 table 3 times, 3 table 2 times, 2 root 3 by 3 will be there. So this is 2 by root 3 will be correct only. No need to think wildly. Yeah. Next, because we only forgot angular momentum L is equal to mvr sine theta. R I forgot to write. Yeah. Next. That's why data interpretation is important. Two bodies of masses 4m and 9m are separated by distance r. The gravitational potential at a point on this line joining them where the gravitational field becomes 0. Gravitational field becomes 0 at x is equal to r by square root of m2 by m1 plus 1. That means r by square root of 9 by 4 plus 1. That is r by 3 by 2 plus 1. That is 2r by 4, right? No, 5. 2r by 5. We should be very careful while doing sums. So this is 2r by 5, that is equal to x. So from first mass, 4m mass. So now potential V is equal to V1 plus V2. V is equal to minus Gm by x1 for 1 minus Gm2 by x2. x2 is nothing but r minus x1. So minus g can be taken common. This will be m1 by x1 plus m2 by r minus x2, r minus x1. So that is equal to minus g into m1 is 4m by x1. x1 I got as 2r by 5. 2r by 5 plus m2 is 9m. 9m by r minus 2r by 5 is r minus 2r by 5 is 3r by 5. So 3r here by 5 is here. So what can be taken common? Minus g. 5m can be taken common here. And by r also comes out. What are left out things? 2 times will go plus 3 times will go 3. That's it. M by r everything came out. So 5 it is. 5 5 is 25. 25 gm by r with a negative sign. 25 gm by r with a negative sign. Oh, in that aspect only g value not substituted. Fine. Next. A satellite revolving around a planet has orbital velocity 10 km per second. Orbital velocity V0 is equal to 10 km per second. Additional velocity required for the satellite to escape from the gravitational field of the planet is, additional velocity needed is, satellite revolving around the planet has orbital velocity 10. Okay. And he didn't mention that is close surface satellite or any other. He didn't mention that. So, but if we take that as a surface satellite, 11.2 kilometers per second we want actually. So 11.2, that is already 10. So normally it is 1.2, but there is no option for that. The additional velocity required for the satellite to escape from the gravitational field of the planet is. So we need to check out the numbers also once again. No, orbital velocity is this one. Escape velocity is equal to root 2 times of orbital velocity we have. So root 2 times into 10 is this one. So this is 1.414 into 10. So this will be obviously 14.14. Maybe this is his question. So 14.14 is escape velocity. Already 10 is having. So additional velocity is equal to 14.14 minus 10.00. So that is equal to 4.14. So we need to understand the mindset of the paper setter. Okay. Yes. Next. Two bodies of masses 8 kg are placed. Two bodies, both are 8 kg only. I'll check. 8 kg are placed at A and B of an equilateral triangle ABC. Third body of mass 2 kg is placed at centroid G, and AZ is equal to BZ and CZ is equal to 1 meter. I think so. Let me check out all these numbers so that time will. Yeah, corrected the numbers. We'll continue. This there is a triangle. Okay, this is centroid. Here 8 kg. Here also 8 kg. Okay, and here is 2 kg. Now this one equal to this one. Resultant force, first of all, we can calculate force F1 is equal to F2 is equal to F0. Two forces will be equal. That is how much G M1 M2 by R square. The distance I want to take up as 1 meter he gave. This is AG, BG, CG equal to 1 meter. So this is G only, G. So this is A and this is B. So obviously it is 1 meter square. So A2s are 16G it is. Okay. Now they are at 120 degrees actually. So their resultant will come like this. Their resultant will come like this. So resultant, F resultant of 1 comma 2 is equal to 120 degrees. Whenever two equal forces are at 120 degrees, then the resultant is equal to one of the force. So 16G only the resultant. Now, if 16G is like this, where we have to put the other mass of 4 kg at a distance d such that net force will be 0. That means 16G must be balanced by G M1 M2 by d square. So GG gets cancelled, GG gets cancelled, and 2 4s are 8 will go. So 2 times 2 equal to 1 by d square. D is equal to 1 by root 2. Simple question only, but description is a lot. A satellite is orbiting close to the Earth's surface, has a kinetic energy A. The minimum extra kinetic energy required by it to just overcome the gravitational pull of the Earth is already orbiting with A. Then minimum energy needed to overcome the attraction force. See, already it is orbiting with A. That means you see kinetic energy equal to A, he said. Kinetic energy A, but in the options it is K only. So we will make it as K only. Okay. So kinetic energy is equal to, kinetic energy is K. If the kinetic energy is K, what about total energy? Total energy is equal to minus K, isn't it? If the total energy becomes 0, then it can escape. If the total energy becomes 0, then it can escape. If you want to make it 0, how much extra energy you have to give to make it 0? That means minus K plus delta equal to 0, then delta needed is equal to K. So one more K is needed to escape. I repeat, total energy minus K. If total energy becomes 0, it escapes. It escapes. So how much? See, I have minus K, loan of minus means loans. Loan K I have. When will I free? If the loan is cleared. That means how much I want? That much I want. That's it. Which of the following graph correctly represent the variation of G on Earth? Oh, this one only. Because G proportional to R inside, G proportional to 1 by R outside. This is outside, this is inside. So graph B. Okay, next. The value of acceleration due to gravity at a depth GD is equal to 6 sentence construction. Depth of D is equal to 1600 kilometers equal to. So GD is equal to G into 1 minus D by R. 1 minus, this is 9.8 into 1 minus 1600 by 6400, almost all 4. So this is 4 ones are 3 by 4. 3 by 4 of 9.8. If it is 10, 10 by 4 is 2.5. 2.5 3s are 7.5. Nearest to 7.5 is 7.5. That is option C. That is not comma, that is point. Let me change in a minute, and I'm not pausing the video. I'm just trying to change it into point. I changed. Yes. Next. If the mass of the body M on the surface of the Earth, the mass of the same body on the surface of the Moon is, mass remains unchanged. Excellent bit it is. Mass remains unchanged. only weight will change because acceleration due to gravity will change. Two identical particles M go round in a circle under the action of their mutual gravitational attraction. The angular speed of each particle will be two identical particles go round, okay, and their separation is 2r and radius is r. Here he said circle of radius a, so this is 2a. Okay, now gravitational force of attraction is gm into m by 2a square. Gravitational force is equal to centripetal force or centrifugal force, mv square by r. M, he is asking v only, angular speed, so mr omega square must be used. mr omega square. So mm gets cancelled and omega square is equal to gm by 4a cube. So omega is equal to square root of gm by 4a cube. Gm by 4a cube. Yes. Next, energy required to move a body of mass m from an orbit of radius 2r to 3r. Energy required to move a body of mass m from an orbit of radius 2r to 3r. Total energy in an orbit is given by minus gmm by r. So final energy minus initial energy, total energy final minus total energy initial, that is equal to minus gmm can be taken common, 1 by orbit of 3r. So r value I have to write, first final one is 3r minus initial one is 1 by 2r. So r also comes out, minus gmm by r also comes out. It will be 2 minus 3 by 2 3s are 6. So it will be minus 1 by 6. So gmm by 6r is the energy needed. Yeah. Total energy will be changed. Next. These are the questions based on gravitation. Okay. You keep on practice. Even our lecture sheet we discussed, practice sheet you do and come with good number of doubts.